Mr. Sri Ganesh V. Gaikwad, Associate Professor, Department of Chemistry, DBF Dayanand College of Arts and Science, Solapur. Now today we are going to discuss the topic chemical kinetics. Now in this chemical kinetics you must know first the what is meant by chemical kinetics and its scope. Chemical kinetics is a branch of physical chemistry which deals with the study of velocity of a reaction or rate of chemical reactions. Such a study helps to understand the mechanism through which the reactants are transferred to products. Almost all chemical reactions take place under a set of conditions. For example, temperature, pressure, concentrations of reacting substances. Again, presence of catalysts, etc., etc., etc. An increase in temperature will increase the rate of reactions. Similarly, increase in concentrations increases the rate of reactions. That means the temperatures and concentrations are directly proportional to the rate of reactions. However, it is observed that many reactions take place at such a fast rate so that it is not possible to measure the rate of such reactions, that is the ionic reactions. So it is not possible to measure the rate of ionic reactions because of they are fast. Now what are ionic reactions? So ionic reactions are nothing but the reactions which take place between the ions are called ionic reactions. For an example, neutralizations of acid by base. On the other hand, there are some reactions which require such a long time, that is, it is impossible to measure their rate. For an example, reactions of or the reactions between oxygen and hydrogen in presence of catalyst. Besides this, the molecular reactions which take place between non-ionized molecules are called molecular reactions. For an example, hydrolysis of cane sugar. So, the reactions for this hydrolysis of cane sugar is C12H22O11 plus H2O gives C6H12O6 plus C6H12O6, that is glucose and fructose. The molecular reactions proceeds with measurable velocity. The velocity can be determined from time to time by following a definite scientific procedure. So now all of you know that the chemical kinetics is a branch of physical chemistry which deals with the study of velocity of reactions. Now let me try to define the velocity of reaction. So definitions for velocity of reaction: the amount of substance decomposed per unit time, the unit of time being chosen such that the velocity remains constant in that time interval. Suppose that dx is the small amount of substance decomposed in a very small amount of time, namely dt. Then the ratio dx upon dt will give us the velocity of a reaction. Or we can also define the velocity of reactions in another way, that is the rate at which the concentration of reacting substances vary with the time. Suppose that if C is the concentrations of the reactant at a time t, then the velocity of reaction is equal to minus dc upon dt. Here the negative sign indicates that the concentration of the reactant goes on decreasing with respect to time. So minus dc upon dt is also nothing but the velocity of reactions. At the same time, dx upon dt is also nothing but the velocity of reactions. So in the definitions, minus dc upon dt, the negative sign is used to indicate that the concentration decreases with the time. According to the law of mass action, the rate of reaction is proportional to the product of the concentrations or the active masses of the reacting substances. As the reactions proceeds, the reacting substances gets continuously consumed, and hence the rate of reaction decreases continuously with the time. The variation of velocity with the time is as shown in the figure. So look at the figure graph. In this graph we come to know that the velocity of reactions goes on decreasing with respect to time. The reaction rate becomes slow and slow, but it is never be zero. That is, infinite time would be required for the rate becomes zero. However, in practice the rate becomes so slower after certain time interval that it may be considered practically zero. That is, reactions would be said to be complete. The velocity of reaction depends on the nature of the reacting substances, temperatures, concentrations of the reactants, and the presence of catalyst. Now let me try to discuss now the rate constant or specific reaction rate. So according to the law of mass action, the rate of chemical reaction is proportional to the concentrations of the reacting substance or the product of the concentration of the reacting substances. Now let us consider reactions. A plus B gives products. So suppose that if Ca is the concentration of the reactant A and Cb is the concentration of the reactant B at any time t, then according to the law of mass actions, the velocity of reaction is directly proportional to the product of the concentration of the reactant, that is minus a dc upon dt directly proportional to the Ca into Cb, or dx upon dt directly proportional to Ca into Cb. Now mathematically, so this minus a dc upon dt directly proportional to Ca into Cb is equal to K into Ca into Cb, or dx upon dt directly proportional to the Ca into Cb is equal to K into Ca into Cb. Here K is proportionality constant and it is known as rate constant or velocity constant, or it is sometimes it is also called as specific reaction rate. It is a constant at a definite temperature for a given reaction. When concentration of the reacting substances is unity, then Ca into Cb is equal to 1. Therefore, minus dc upon dt is equal to K, or dx upon dt is equal to K. That is, the specific reaction rate is defined as the velocity of reactions when concentrations of all the reactants are unity. So we can also define the specific reaction rate, the velocity of reaction when the concentration of all the reactants are unity. It is a constant at constant temperature. It depends on one, order of reactions, and second, the temperature. Now let me try to discuss the units of velocity and units of velocity constant. The velocity of reaction is nothing but the change in concentration of reactants per unit time. Therefore, the velocity has dimensions of moles per liter per second or moles per dm cube per second. Moles per dm cube per second. The units of velocity constant. The unit of velocity constant K depends on the order of reactions. For first order reactions, now we know that the rate of reaction is directly proportional to the concentrations. Hence, minus a dc upon dt is equal to K into C. Therefore, K is equal to minus a dc upon dt into C. Now, let me try to write the units for concentration term and time term. The unit for concentration term is moles per dm cube and unit for time term is moles per second. Simply per second, only second. So, the unit for velocity constant for first order reaction is moles per dm cube divided by moles per dm cube into second, or from this we come to know that moles per dm cube from numerator and moles per dm cube from denominator gets cancels and simply you will get 1 upon second. So second inverse is the unit of velocity constant for first order reactions. Similarly, for second order reactions, the unit for velocity constant is, so for second order reactions, the rate of reaction is directly proportional to the square of the concentration of the reactant. So therefore, minus dc upon dt is equal to K into C square. Therefore, velocity constant K is equal to minus dc upon dt into C square. So again, write the units for concentration terms and unit for second term. So is equal to moles per dm cube divided by moles per dm cube bracket square into second. So moles per dm cube from the numerator and moles per dm cube from the numerator gets cancels. So now write down the remaining terms, that is 1 upon moles per dm cube into second. So is equal to dm cube per mole per second is the unit for velocity constant for second order reactions. So in general, the unit is for second order velocity constant for second order reaction is the dm cube per mole per second. So in general, for nth order reactions, the unit of velocity constant Kr time inverse into bracket concentration bracket raised to n minus 1. So now let me try to discuss what are the factors affecting on the rate of reactions. So various factors are affecting on the rate of reactions, and these are nothing but the concentrations, pressure, temperature, catalyst. So let me try to discuss one by one. So concentration is directly proportional to the rate of reaction. So if you increase the concentration, the rate of reactions goes on increasing. Similarly, if you increase the pressure, the rate of reactions also increases. If you increase the temperature, the rate of reaction is also increases. In most cases, rise in 10 degrees centigrade temperature double or triples the rate of reactions, that is dx upon dt is equal to 2 or 3. Similarly, catalyst also increases the rate of reactions. Some catalyst increases the rate of reactions or some catalyst decreases the rate of reactions. The catalyst which decreases the rate of reactions are called as negative catalyst, and the catalyst which increases the rate of reactions are called as positive catalyst. So catalyst generally increases the rate of reactions at a given temperature. However, its action is specific. A particular catalyst can catalyze to a particular reactions only. For an example, the decomposition of potassium chloride reaction is catalyzed only by manganese dioxide powder. So KClO3 MnO2 is the catalyst, gives twice KCl plus 3O2. Similarly, hydrolysis of methyl acetate is catalyzed by using hydrochloric acid or sulfuric acid. If the substance records the rate of reactions, then it may be called as a negative catalyst or inhibitors.